Okay, we're going to be taking a few days and looking at exponents again. So a lot of this first material is going to be familiar to you, but it'll be presented in a little bit different way. Okay, well, if we talk about exponents, if you look at 3 to the first, that's going to be 3. 3 squared is 9, of course, because you are doing 3 times 3. 3 cubed is going to be 27 because that's 3 times 3 times 3. So if you'll notice, every time you increase the exponent, as you move to the right, you are multiplying by 3. Okay, now, if I move to the left, so if I start with 27, 3 cubed, and I move to the left, then to decrease the exponent, you are dividing by 3. So 27 divided by 3 is 9. If we do it again, move to the left, so you're dividing by 3. 9 divided by 3 is 3. And then if you keep that pattern, follow that pattern, you're going to find that 3 to the 0, well, do 3 divided by 3 is 1. And that's one of those exponent rules. Anything to the 0 power is 1. Okay, now as you move into negative exponents, it's still going to hold that same pattern. So if I do 1 divided by 3, it's going to be 1/3. 1/3 divided by 3 is going to be 1/9. And 1/9 divided by 3 again would be 1/27. Okay, now there is another way that we talked about negative exponents. So we talked about how if you have a negative exponent, that means do the reciprocal. Okay, so you could think of it that way. So 3 to the negative first, the reciprocal of 3 is 1/3. Okay, 3 to the negative second, well, that'd be 1 over 3 squared. And then that 3 squared is your 9, so 1/9. And then same thing here, 3 to the negative 1/3, you could think of that as 1 over 3 to the third. Again, the reciprocal, 1/27. Okay, so that pattern is going to hold true for anything. Okay, so any number you want to choose, or if you were working with variables to negative exponents, it's the same concept. Okay, here in example 2, we have a little bit of function notation. So we're supposed to find f of 2. So f of 2, I'm going to take this equation here, this is what I'm using, is going to be 20 times 2, and my exponent is x, so that's where my value of 2 is going to be. And this turns into 20 times 4 and 80. So f of 2 is 80. Okay, if we put in 0 for x, so f of 0 is 20 times 2 to the 0 power. So that's going to be 20 times 1, or f of 0 is 20. Okay, then f of negative 2, so negative exponent this time. So 20 times 2 to the negative 2 power. Okay, well, negative 2 power, that's going to be 1 over 2 squared. So this is going to be 20 times 1/4, or f of negative 2 is 5. Okay, now there's something else I want you to notice about the pattern here. So f of 2 is 80, f of 0 is 20, f of negative 2 is 5. Okay, so can you, if you think about this for a second, without calculating it, if you know that f of 2 is 80 and f of 0 is 20, do you have a guess as to what f of 1 would be? Okay, now, if you're kind of saying, well, no, maybe halfway in between, you're not far off, but f of 2 is 80, f of 0 is 20. What do you think maybe f of 1 is? Okay, and if you said 40, you are correct. F of 1 is 40. So to plug that in, the f of 1 equals 20 times 2 to the first power, and that would be 40. Okay, so there's a definite pattern here. So if you start with f of 0 is 20, f of 1 is 40, f of 2 becomes 80. Okay, so do you see what the pattern is? If I go from 20 to 40 to 80, Okay, you might say, well, you're multiplying by 2. You're right. So 20 times 2 is 40. 40 times 2 is 80. Our next one, f of 3, 80 times 2 would be 160. Okay, so that's, so you can tell that we're multiplying by 2 to get to the next value. That's what this number in this equation does. This is called a growth factor. And we'll come back to that in a couple of days. Okay, but it's that growth factor that tells you you're going to be multiplying by 2. Another way you can think about it, instead of just thinking multiply by 2, you can think about it as being doubled. My value is getting doubled. Okay, so if I mow grandma's yard this week and I get 20, she pays me $20. I come back next week, I mow her yard and she gives me $40. Your pay just doubled. Okay. All right, so what if that factor is a 3 instead? So instead of it times 2 to the x, what if it's times 3 to the x? What will that increase be? And that would be triple. You would be tripling your value. Okay, so example 3 here, the next couple examples are just some basic exponent rules that we have worked with before. So a 2 cubed times 2 to the 4th, that's just going to be 2 to the 7th. Okay, so remember, add exponents on that. 2 to the 6th times 2 to the 2nd, that'd be 2 to the 8th. And then if it's 2 to the m times 2 to the n, well, that would be 2 to the m plus n power. Okay, so example 4 is, well, what about if you have a negative exponent? Does the same thing still work? Okay, well, if I make the assumption that all I need to do is add those exponents, then I get 2 squared. Okay, all right, well, what if, for part B, evaluate 2 cubed times 2 to the negative first by first rewriting 2 cubed and 2 to the negative first, then simplifying. So, okay, so 2 cubed times 2 to the negative first. Well, 2 cubed would be 8, and 2 to the negative first would be 1/2. 8 times a half, you get 4. Is that the same thing as 2 squared? Yes, 2 squared is also 4. So it looks like that same rule, you can still use that rule even if you're working with negative exponents. Okay, let's go down to example 5. So this one, 3 squared cubed. Okay, this is going to be 3 to the 6th power. This is the power to a power property. If you remember us talking about that. So 3 to the 4th squared, that would be 3 to the 8th. Okay, what are you doing? You are multiplying those exponents together. So power to a power, multiply your exponents. And again, does the same thing work if we use that same rule on negative exponents? So if we do that here, that would be 3 to the negative 8 power, which would be 1 over 3 to the 8th. Okay, all right, so same kind of thing. Does that match if we rewrite the 3 to the negative 2 power? Okay, well, if we go 3 to the negative 2 power, that's going to be 1 over 3 squared to the 4th, or 1/9 to the 4th power. So that's going to be 1 to the 4th over 9 to the 4th. And 9 to the 4th is 65/61. Okay, so there's that fraction. Well, we need to go back over here. If I do 3 to the 8th power, that's the same thing, 1 over 6,561. So yes, that power to a power product where we multiply our exponents, that will also work if you're dealing with negative exponents. Okay, and that is it for today. Okay, as far as homework, you will find a homework posted that goes along with this lesson. But as I told the students in class, it is not an assignment. What I do ask you to do is take about 5 minutes and read through it. You'll see the homework is posted along with an answer key. So if you would do that for me, please, that would be great. I will see you next.